Hello friend, today we are going to discuss about statistical process control, which is also known as SPC. This is actually second edition of the SPC, which were published in July 2005. In this session, we are going to discuss about what is SPC, what are the aim of SPC, what is benefits of SPC, and what is CP, CPK, PP and PPK, what is the variation, what are the causes of the variations, means what are the common cause or what are the assignable causes, what is control charts, means that is variable control charts, attribute control charts, and what are the X bar and R chart. These things we are going to discuss about one by one in details. First, what is statics? Actually, statics is dealing with designing for collection of data, means data analysis, interpretations, and initiating action based on the analysis. Means data collection, data analysis is known as statics. Dealing with data. Process is actually converting an input into output by using man, machine, material, method, and environment is known as process. What is the control? Actually, control is ensuring to make a variable to be within the stated limits is known as controls. Control means within the stated limit. What is SPC? Actually, SPC is controlling the process variations by using statics is called statistical process control. What is variations? Means no two parts, means no two products are characteristic are exactly alike. Means process contain many sources of variability. The difference among products may be large or they may be immeasurably small, but they are always present. Means variation is always present in process, in product. Okay, what are the causes of these variation? Actually, these causes can be common cause, that also known as chance cause, and second one is assignable cause or special causes. We are going to discuss about one by one what are the common cause and what are the assignable cause. First is causes of variation is common cause or chance cause. Actually, these variations is many sources of little variations within a process that has a stable or repeatable distribution over time. Means this is repeatable distributions. Means the process output will be predictable. Means the variation is always present in process. That is repeatable distributions. That should ensure the output is predictable. Resolution of these causes usually requires action on the system, means 80% action is based on management decision and 20% on local feedbacks. The example of the common causes is differences in weather conditions, environmental conditions, and accuracy of measurements and capability of the machines is the example of the common cause variation. And what are the assignable cause? Assignable causes is actually is also known as special causes, single source of variation. These are the not many sources of variation. These are single source of variations causing high variations that makes the process distribution change. The process output is unpredictable. These process output is unpredictable because the single source causing high variations. Okay, especially during the early process improvement if effort. Actually, a resolution of these causes usually requires local action, especially during the early process improvement efforts. What is the example of the assignable or special causes? First is human error, means mistakes, lapses in concentration. Second is incorrect measurement and incorrect assembly, incorrect operations of machinery, incorrect data entry, incorrect calculations. And third one is tool wear out, means tool wear out, tool punch broken, insert broken, and tool cavity damage, that is the tool wear out. Tool guide pin broken, tool guide pin wear outs. Okay, and fourth one is poor maintenance, means maintenance like predictive maintenance, like preventive maintenance, like time based maintenance, like overhauling is poor. This is a process under development. We can see the figure in from top to bottom process is developed. Frequency of variation. This is actually the shape of normal curve distributions. The curve which shows frequency of variation of a number of observations for the various values around arithmetic mean. Around the mean number of observation is around the mean. That's why means frequency is high. We are seeing the results, means graph of frequency versus side deviations. The average value has more frequency. These are the frequency of occurrence against the actual variation. Graph will be a normal curve. This is the frequency versus area under the normal curve in terms of standard deviation. Plus minus 1 standard deviation shows 68% approximate, and plus minus 2 standard deviation shows 95% area covered, and plus minus 3 standard deviation shows 99% approximate area covered. What is the types of measurement variations? Means what is local variation, what is width variation. We should explain, we will going to explain one by one what is local variation, what is width, what is the shape, patterns. These things we will discuss. First is variations. Variation, individual measured values may all be different. As a group, they tend to form a pattern that can be described as distribution. The distribution can categorize by, first is location, means all the measured values, average or arithmetic mean is different, means one measurement have mean different and other measurement have mean is different. This is the location error, means measured value or average values have different values. And spread means smallest to largest values. Span means ranges of the values from smallest to largest is known as spread. And shape actually the pattern of variation, whether it is symmetrical, this is positive skewed, negative skewed, is it cyclic, is it continuously increasing or decreasing. That tells about the shape of variations, means patterns of variations. These are the another location, spread and shape of the variation. This is another example of location, spread and shape. What is accuracy and precision? This is important characteristic, accuracy and precision. Actually, accuracy is closeness to the true value, means true value, how close to the true value is known as accuracy. And precision is closeness of repeated measurements is known as precision. If we are looking the examples, first is accuracy and precision. First example, actually all the measured value is in center, is near to true value, near to mean is accurate, and all the measured value is closest to of repeated measurement, means each measurement is very close to another, that is the precise. Means first diagram, if we are looking the first diagram, the measurement is accurate and precise. In second diagram, all the measurement is actually away from each other, but in the near to the center line or near to the true value, that the measurement is accurate but each measurement is different, means not repeated measurement, that it is imprecise, means measurement is accurate but imprecise. In third diagram, actually values are very close to each other, but away from the true value or center value. The measurement is inaccurate, but values are closeness to each other. That should means precise. Means values are inaccurate but precise. In fourth diagram, values are away from the target or center line or true value, but they are uh, actually values are away from the center values, and values repeated measurement is away from each other. Means it is neither accurate nor precise. Means fourth diagram is inaccurate and imprecise. If we are looking the notes up, first is you can correct for bias. We can correct for bias, but we cannot correct for imprecise or not precise. Means we can correct for bias. If there is a error in location, we can correct for it, but we can not correct for imprecision or repeated of measurement. Okay. What is process control and process capability? What is process control? Process control is said to be operating under statistical control when the only sources of variation are from common causes. Means no assignable causes is present. Process is known as under statistical controls. Means only common causes is present, no assignable causes. Process is in control, in statistical control. Process capability. The ability of process to meet customer expectations determined by the process that comes from common causes. Means its ability of process to meet customer expectations is known as process capability, and the variation that comes from common causes only. Basis of continual improvement. Actually, we have already made a video of continuous improvement and continual improvements. What is continual improvement? Actually, improvement with reference to time, with respect to time, by recurring activity. Means zigzag activity. We are doing for example 10% improvement, then we sustain it, again we are doing 10% improvement, again sustain it, again doing 10% improvement, again sustain it. That known as continual improvement. Means recurring activity is known as continual improvement. In continuous improvement, actually improvement with reference to time, but no any sustains activity is done. Means we are doing the improvement, like we have done 60% improvement. If any mishappening happened, we can false maybe to zero improvement. But in continual improvement, if any mishappening happened, we can false previous step. Means if we are at 60% improvement, we can false on 50% improvement. Means 50% improvement already sustained. Okay, that was the difference in continuous and continual improvement. We have already made a video of IATF basis. In that we are explaining the continual and continuous improvement. In terms of SPC, basis of continual improvement, process must first be brought in to statistical control. Means process have no assignable causes. By detecting and acting upon special sources causes of variation, then its performance is predictable. Means no assignable causes, no special causes, process is predictable, and its capability to meet customer expectation can be assessed. Now we are going to discuss about control charts. Actually, control chart is basic tool of SPC, which used to find out whether system is under control or not. It consists center line with straight line and upper and lower control limits with dashes line. We are representing by continuous line to center line and dashes line with control limit. First, actually phases is, there are three phases. First one is collection. means data gathering, and plot on a chart. Means data collection, data analysis and plotting is a first phases. Second is controls, calculating trial control limits for upper control, lower controls limits from the process data, and identify special causes of variation, and if any special causes identified, then act upon them. And third one is analysis and improvements, quantify common causes of variation and take action to reduce it if any common causes of variation is available more than the means more amounts or more limits, that we should also act on that common cause. Okay, these three phases are repeated for continual process improvements. First is collection, data collection and plotting on chart. Second is controlling, means upper control, lower control limits, and if any there is any special cause a special cause variation is assignable cause variation is present, we should act on it, remove it. And third one is analysis and improvements. Types of control charts. First is variable and second is attribute. Variable, if we are talking about variables, that is X bar and R chart. Second is X bar and S chart. S is standard deviation. X median chart and range chart. And fourth one is XMR, moving range chart. Okay, means X mean mean and moving range chart. Second is attribute. Attribute have two categories, for defective and defective per unit, NP and P chart respectively. And for defects, C and U, means C is for defect and U is for defect per unit. These are the attribute charts. We have 4 attribute charts and almost 4 variable charts. This is the diagram that when we are going to select which control charts, means in variable, if number of sample size, means number of subgroup size is 1, then we should choose the means less than 1 or not greater than 1, we should choose the XMR chart. And if n number of subgroup sizes, means number of subgroup sizes, if subgroup size is more than 1 or more than 1, then we should go in X bar and X bar S chart. If it is greater than 10, then we use X bar X chart, and if it's less than 10, means greater than 1 but less than 10, we should use X bar R chart. In terms of attributes, constant sample size, means sample size is constant. If sample size is constant, we should use PR and P chart. If no, then we can use PR and P chart. Means PR and P chart, sample size is constant or can be variable, varying. And constant sample unit, if sample unit is constant, we use C chart. If no, then we use U chart. Means in variable, if sample size is greater than equal to 1, we can use X MR chart. And if sample size is greater than 1 but less than 10, we can use X bar R chart. And if sample size is greater than 10, we should use X bar S chart. Benefits of control chart. What are the benefits? First is help understand the process variation. Second, indicate when action should be taken or not. If any assignable causes is present, any assignable causes is showing in the chart, we should remove it. And third one, show evidence that process is in control or not. Are part of is actually control chart is a part of improvement process and provide a common language for communicating information and indicate the extent of common cause of variation, but the causes themselves need more detailed analysis to isolate. And last one is detect a special cause of variation and allow to take appropriate actions. These are the benefits. Now we should explain one by one control chart for variable and attributes. First one is control charts for variables. Variable charts explain process data in terms of location, means average. Second is spread, range or standard deviations. These two parameters are variable charts. Note, the shape cannot be identified with control charts. Kind of control charts is first is X bar R chart, as already explained, means average and range chart. X bar S chart, that is average and standard deviation chart. X M and R chart means median and range chart. And last one is X MR chart, means individual and moving range chart. Control chart for attribute. When used, output results only indicate two possibilities, that is pass or fail, OK or NG, and qualified or not qualified. Attribute charts explain process data in only one term of proportion or number kind of charts, means proportion or number. Attribute chart explains only one term, proportion or numbers. What are the kinds of charts of attribute? First is P charts, means proportion of non-conformity units, non-conforming units. NP means number of non-conforming units. P is proportion, NP is number of non-conforming units. For defects, C chart is number of non-conformity and means defects, and U is defect per units, means number of non-conformity per units. Advantage of the attribute chart is easy to measure, require data which is most of the time readily available with inspection record. Preparation for use of control charts. Establish an environment suitable for action, define the process, determine the characteristic to be managed, considerations, the customer needs, current and potential problem area, correlation between characteristics, means define the measurement system, minimize the unnecessary variations. What are the guidelines for data collection for plotting control charts? Process data is collected in number of subgroups. Each subgroup is of defined sample size, and these sample groups are selected as a defined period, means frequency. In diagram showing is first, second, third, fourth. This is the subgroups, and for three dots, and between subgroup we have defined the frequency, means frequency of data collection. Guideline for sampling process data collection. Selection of subgroup size, frequency and number of subgroups. Control charts for variable. This is variable, what are the subgroup size, what are the subgroup frequency, number of subgroup size. This the intention should be the pieces within each subgroup would be produced under very similar production conditions over a very short interval. If the variation within the subgroup represent piece to piece variability over a very short period of time, then any unusual variation between subgroup would reflect changes in the process that should be investigated for appropriate actions. And subgroup frequency, the goal is to detect changes in the process over time. And subgroups should be collected often enough and at appropriate times that they can reflect the potential opportunity for the changes. means this actually subgroup frequency should be defined the criticality of the that characteristic, that measurement. If it is very critical, then we should increase our subgroup frequency. Okay, if it is not characteristic, mean increase means we should take the samples more and more. Number of subgroup, the criteria from process standpoint, enough subgroups should be gathered to assure that major sources of variation have had an opportunity to appear. Means we should gathering major sources of variation, we should take more number of subgroups. This is an the criteria. Generally subgroup size should not be less than 4, means more preferable. It should be 4, 5 or 6. Number of subgroup generally should selected more than 20. The more preferable relationship between subgroup size and K, number of subgroups, subgroup size and number of subgroup. A small batch size, more number of batches means higher frequency, easier to identify assignable causes or special causes. To plot initial control limits, minimum 100 samples are advisable for 100 samples. Means subgroup size and sample size is n is equal to 4, and subgroup number of subgroup is 25 and subgroup size is 4, and it can be if we are taking subgroup size is 5, number of subgroup will be 20 per 100 readings or 100 samples. Average and range chart means X bar and R chart. Gathering data, subgroup size initially 4, 5 or 5. Consecutively produced pieces from a single process stream must remain constant for all subgroups. All pieces would be produced under very similar conditions. Subgroup frequency initially short interval and can be lowered once the process has demonstrated stability. Changes in the process over time must be detectable. Number of subgroup, initially minimum 25. Subgroups provided minimum 100 ratings. Major sources of variation must have opportunity to appear. Means number of subgroup, subgroup size is 4 or 5. Number of subgroup is 20 or 25. Means minimum 100 rating required. Subgroup frequency initially short and can be lowered down once process is stable. What is control chart for variable? Average and range chart is continued. Is set up control charts and record data is by denoting by X, and individual reading sample size denoting by N. Calculating the average and range for each subgroup. This is first subgroup is X1, second is X2. These are the readings actually. X1, X2, X3 and Xn. These are the N readings divided by N. This is sample average actually, X bar. Ranges is what are the maximum reading, what are the minimum reading in this. This subgroup size are these samples. Average and range charts, we are going to calculate control limits. Means calculate average and range, process average. Average range and process average. First is actually in right side, average process X bar chart. X double bar is X1 bar. Means if we are taking the sample size of sample size or subgroup size of 4 or 5. If we are taking subgroup size of 5, then X1 plus X2 plus X3 plus X4 and X5 divided by 5, that is X1 bar. And X2 bar is second group, X6, X7, X8, X9, X10 divided by 5, that is X2 bar. That's we are making the XK bar, means number of subgroup we are making is K. Subgroup size is 5. Average chart Average chart is actually x double bar is average chart, means central line. Upper control limit is x double bar, means central line, plus A2 into R bar. R bar is max minus R bar is actually R is max minus min, and R bar is, that is R1. R1 means x1 to x5. What are the maximum and minimum differences, means what is the differences in max and min is R1, and R2 is x6 to x10 reading. What are the maximum and minimum differences is R2. That's R bar is R1 plus R2, that's RK divided by K is actually is known as R bar, and LCLX is x bar minus A2 is constant. Actually we find the values from the constant table of SPCs, and R bar. Similar average range is R bar chart is R bar is R1 plus R2 plus RK divided by K, already explained. Calculating the control limits for R chart is R chart central line is R bar, okay, and upper control limit is D4 R bar, lower control limit is D3 R bar. If subgroup size is, means number of subgroup, means subgroup size is less than 7, then the value of D3 will be 0, means control limit will be 0, lower control limit will be 0. Estimated process standard deviation sigma is R bar by D2. In this formula, actually for R bar and X bar chart, we are using sigma is between standard deviation. Okay. Note, there is no lower limit for ranges for sample size below 7. That already explained, means lower control limit for R chart is 0. This is table of the constant. Statistical process control study. This is the format of the how to control CP and CPK, X bar and R chart, range and average chart, and histogram also. This is a format, general format. You can make your own format. What is the inherent process variation? What is between subgroup variation, between subgroup variation, and total variations? Actually, first is between subgroup variations, means this variation is due to only between subgroup, also called between system variation, means the variation is between system, not between system, is system between system, means variation is between subgroup. What is the minimum, what are the maximum, what are the average, that variation is known as between system. What are the minimum values and maximum values, what are the differences of max minus mean, that variation is between system variation. And if process in statistical control, this variation is a good estimate of inherent process variation. It can be estimated from control chart by formula using sigma C R bar by D2. Between subgroup variation. Between subgroup variation means subgroup 1, subgroup 2. Variation between subgroup 1 and subgroup 2 is known as, means variation between K1, K2 is K3, K4 is known as between subgroup variation. This variation is due to the variation between subgroups. If the process in statistical control, the variation should be near to 0. What is total variation? Means between system variation and between system variation. Both variation means total process variation, that denoted by sigma p or s. This is the variation due to both between system and between subgroup variation. Between subgroup, between subgroup, between system, between subgroup, between system variation. The process is not in statistical control. The total variation, if process is not in statistical control, total variation will be included the effect of special cause and common cause. Means this variation is also effect of common cause and special cause variation. Both variation is present in total process variation. Mean within subgroup variation, between subgroup variation, within system, between system, common cause and assignable both cause of variation is present in the system is known as total process variation. They are denoted by sigma p or sigma s. The formula is under root summation of xi minus x bar का whole square divided by n minus 1. Xi is individual reading like x1, x2, x3, x4, x5 is we are taking 100 reading x 100, and x bar is average reading. X we are taking subgroup size of 5 5. Then x1 to x plus x2 plus x3 x4 x5 divided by 5, x6 x7 x8 x9 x10 divided by 5, and another pair we are making, that is average reading. And n is total number of individual reading. What are the reading? In case of 100 reading, 100 reading, if we are taking subgroup size of 20 or 25, means subgroup size of 4 or 5, then total number of subgroup will be for 100 reading 20 or 25. In case of 4, subgroup size of 4, 25 subgroup size, and in case of subgroup, we are taking the subgroup size, subgroups of 5, then number of subgroup will be 20 per 100 reading. Total process variation. For total process variation, we are using standard variation is sigma p. This is overall variation, and for within system variation, we are using sigma c, that is within system variation. Means sigma c is using for Cp and Cpk, and S or sigma p are using for Pp and Ppk variation. Means Cp and Cpk variation is short-term process capability, and for means process capability, and for process performance we are using Pp and Ppk. That in that case sigma are using sigma p or sigma s, means total process variations. Process capability and process variation performance. Process capability. This 6 sigma range of inherent process variation for statically stable process, means there is no assignable causes, is known as process capability, denoted by sigma c. Process capability denoted by Cp. Process capability denoted by Cp. But in this case we are using this sigma c, means within system variation sigma, that denoted by sigma c. The formula is r bar by d2. d2 is a constant given in SPC constant table. And second, process performance. In process performance, the 6 sigma range of total process variation, means within system and between system, that represented by actually process performance is Pp and Ppk. Pp is process performance, Ppk is process performance index, but sigma is using by Cp. In process performance we use sigma of Cp or S. Formula is S is equal to under root summations xi minus x bar ka whole square divided by n minus 1. If process in statistical control, the process capability will be very close to process performance, means process is in statistical control, means process capability and performance should be very close. If large differences between the capability and performance, that indicate the process have some special or assignable causes is present in that process, we should remove that special or assignable causes. Process capability and process performance continued. Process capability. For process capability and process capability index, we are using sigma c, means within system variation, means there is no common variation, means only assignable means there is no assignable variations, only common causes of variation is present, is known as process capability, means that denoted by Cp. Process capability denoted by Cp. C is capability, P is process. Formula is USL, upper specification limit, minus LSL, lower specification limit, denoted by 6 sigma c. Sigma c is within standard deviation, means within stated means within subgroup variation, means within system variation. Notes, and this sigma c is equal to actually r bar by d2. Note, Cp is not impacted by process location. This can be calculated by the two-sided bilateral tolerance. This actually formula is for two-sided bilateral tolerances. Cp is not impacted by process location. Means if we have process location, means average of all the measurement not impacted by Cp. Your average is where Cp does not impacted, but your spread impacted the Cp. If your spread is very close, then Cp will be okay. Whether the center of the that values is outside the tolerance, but Cp will be okay. But in case of Cpk, this is the capability index actually. It takes the process location as well as capability into account. Means all the values, spread of the values should be close first, and second, the average of the values should also do near the target or center line. Means process capability index impacted by process location as well as capability into account. For bilateral tolerance, CPK will always be less than or equal to Cp. That's the reason already I explained, because Cp is not impacted by process location but Cpk is impacted. That's why Cpk always less than Cp. Cp less than or equal to Cp indicates an opportunity for improvement, means for centering the process. If we are centering the process, Cp is equal to Cp. Cpk is equal to Cp. Cpk is calculating as the minimum of CPU, process capability of upper R, and process capability index lower. CPU formula is USL, upper specification limit, minus x d bar divided by 3 standard deviations, that is within system variation, within subgroup variations. CPL, process capability for lower, process capability index for lower, that is x double bar minus LSL is divided by 3 standard deviation. Which value is minimum, means CPU is either can be minimum or CPL can be minimum. Which are minimum is value of CPK. For PP and PPK, formula is same, but the value of standard deviations, means sigma, is different. Means in these conditions, PP, what is the formula of PP? PP is USL minus LSL, means upper specification minus lower specification limit, that divided by 6 sigma P. P is total process variation between system, between subgroup, between subgroup, and common cause and assignable cause. Both are present. Sigma P or sigma S formula is under root summation xi minus x bar ka whole square divided by n minus 1. Note, and PP is not impacted by process location. That's similar as Cp is not impacted by process location. This can be calculated by two-sided bilateral tolerance. In case of two-sided bilateral tolerance, Cp is not impacted by process location. And actually this formula for bilateral tolerance, and unilateral tolerance we can explain in next slide what are the formula for Cp and PPK. Okay, Cp and CPK, PP and PPK. Process performance index means PPK. This is a performance index. This, it takes the process location as the performance into account. Means as in CPK takes process location as well as capability into account. In this case, takes process location as well as performance into account. For bilateral tolerance, PPK will always be less or equal to PP. That as usual in CP and CPK. PPK less or equal to PP indicate an opportunity for improvement by centering the process. Okay, PPK is calculating as minimum of PPU or PPL. PPU is upper specification minus X double bar divided by 3 sigma P. P is overall variation, means total variations, and PPL is X double bar minus LSL lower specification limit divided by 3 standard deviation. The standard deviation is total process variation. Process capability and process performance for unilateral tolerances. This section discusses the commonly and used indices where the specification has either an upper or lower limit but not both. Means it can be either upper limit or lower limit. CP. CP, this is a capability index, is compares the process capability to maximum allowable variations indicated by tolerances. This index has no meaning for unilateral tolerances. Means CP has no meaning for unilateral tolerances. For example, if the product characteristic has a physical limit, that is flatness cannot be less than 0. A CP could be calculated by using the physical limit 0.0 as a surrogate lower limit, but this number will not have the same relationship to CPK as it does in the bilateral case. Okay, in case of CPK, this is a capability index. It takes the process location as well as capability into account. With unilateral tolerance with a physical limit, CPK can be less or equal to or greater than CP. Means CP can be calculated. CPK can be calculated, but CP cannot be calculated. That's why. For PP and PPK, same. CP for unilateral tolerance, CPK is actually related to proportion non-conforming produced by the process is equal to CPU or CPL depending whether the tolerance is USL or LSL. Means CPK directly related to proportion of non-conformity produced by the process, either CPK, CPU or CPL, that is equal to CP. In case of USL, if unilateral, if USL is given, means upper specification limit is given, then CP is equal to CPU, and if lower given, then CPK is equal to CPL. In case of PP and PPK, performance means for performance and performance indexes. Process performance. This is a performance index PP. It compares the process performance to the maximum allowable variations indicated by the tolerance. This index has no meaning for unilateral. Means PP and CP for unilateral tolerance has no meaning for unilateral tolerance. In unilateral tolerance, PP and CP has no meaning. For example, same as usual given in CP. If the product characteristic has a physical limit such that flatness cannot be less than 0, a PP could be calculated by using physical limit 0.0 as a surrogate limit, lower limit, but this number will not have the same relation to PPK as in bilateral tolerances. And in case of PP and PPK, this is a performance index. It takes a process location as well as performance into account. With unilateral tolerance with a physical limit, PPK can be less than, equal to or greater than PP as usual in CPK. Unilateral tolerances, PPK is directly related to the proportion non-conforming produced by the process is equal to PPU or PPL depending on process tolerance is upper specification or lower. If process tolerance upper specification, then PPK directly related to PPU, and if lower specification limit, PPK is directly related to PPL. Okay. An alternating notation for PPK in case of unilateral tolerance is PPKU or PPKL depending whether the limit is USL or LSL. This is alternate notation. In case of PPU, you can use PPKU, or in case of PPL, you can use PPKL. CR. Actually, this is capability ratio. It is simply the reciprocal of CP. process capability reciprocal is known as CR. And PR is actually, this is also performance ratio simply reciprocal of PP. This indices have no meaning for unilateral. In unilateral tolerance, these indices CR and PR cannot be used. What are the conclusions of process capability and process performances? CPK is approximately equal to CP and PPK is approximately equal to PP. Both of these conditions are indicated the process is well centered. All indices are relatively high, indicating that the process is capable of producing near zero non-conformance if the process remains in statistical controls. Since CP and PP are approximately equal to, it implies minimal between subgroup variation. There means variation will be minimum. Minimal means minimum variation, almost zero variations. A large discrepancy between CPK and PPK would indicate the presence of excessive between subgroup variations. A large discrepancy between CP and CPK also would indicate a process centering problem. Means in CPK and PPK indicate excessive between subgroup variations, and in CP and CPK is process centering problem. Means in case of process centering, CP is equal to CPK, and as usual in PP and PPK is process is in centering, is in center, then PP is equal to PPK also. What is the central tendency? What is central tendency? Means what is mean, median and mode. What is mean actually? Mean is actually arithmetic mean, which is also known as average values. The mean is simply the average values of the data, the most commonly used measures of central tendency. In central tendency, we are most commonly used mean. Example given, the number is 2, 12, 7, 4, 8, 11, 5 and 8, 4 and 8. In these numbers, in this example, we should simply add it. What are the numbers? Number of values is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Means simply sum it and divided by 10. Total values is 69 divided by 10 is 6.9. Means mean or average of the given example is 6.9. Next is median. In case of median, actually we have two methods. One, if total number is odd or even. Median is the values of the middle terms when data are arranged in either in ascending or in descending order. That in example 1, the data is given 2, 12, 7, 4, 8, 11, 5, 8, 4, 8. When number of values in data set is 10, means even. In case of even, that data is also arranging in ascending order, and the values will be 2, 4, 4, 5, 7, 8, 888, 11 and 12. In case of n is even, formula is for median is x 10 divided by 2 reading plus x 10 divided by 2 plus 1 reading total divided by 2, means fifth reading and plus 6th reading divided by 2. Fifth reading in ascending order is 7 and sixth reading is 8. 7 plus 8 divided by 2, that is 15 divided by 2. The median will be in this example is 7.5. But if n is odd, the median formula will be x n plus 1 divided by 2. Simply, if n is even, then formula already explained. Okay, x n by 2 plus x n by 2 plus 1 , 2 . 1 whole divided by 2. 2 . 1 whole divided by 2 . 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 2 This is another example 2 for median. In this case, the data values is 2, 12, 7, 4, 8, 11, 5, 8 and 4, means n is odd. In this example, n is odd, means formula will be x n plus 1 divided by 2, means we are arranging data in ascending or in descending order. In this example, we are arranging data in ascending order, means 2, 4, 4, 5, 7, 8, 8, 11 and 12. This is the order, ascending order. The median will be x, total values is 9. Median will be x 9 plus 1 divided by 2, means 9 plus 1 divided by 2 readings, means 10 divided by 2 reading, means fifth reading. Fifth reading is 7. Median will be 7. In case of mode, actually mode is referred to as the most frequently occurring values in the given data set are given in example. Example 1, the values data set is actually 2, 12, 7, 4, 8, 11, 5, 8, 4, 8. The number of values where n is number of values in data set. Ascending order, we are arranging it 2, 4, 4, 5, 7, 8, 8, 8, 11 and 12. Most frequently occurring values is 8, 3 times, means mode is 8. Example 2, we have data set of 2, 12, 7, 4, 8, 11, 5, 8, 4. If we are going to arrange the values in ascending order, the values will be 2, 4, 4, 5, 7, 8, 8, 11 and 12. Most frequently occurring values is 4 and 8, means 4 and 8 occurring 2 times. Mode will be 2 mode, that is 4 and 8, that is bimode. Note 1, if mode values is more than 2, that mode is multi-mode actually. Example 3rd, the data set is 1, 2, 3, 4, 5, 6, 7 and 8. In this example, there is no values is repeating, means example 3rd have no mode. Okay. Special cause criteria. What are the special cause criteria? In X bar R chart, in standard R chart, what are the special cause criteria? We are going to explain. These are the summary of typical special cause criteria. First is 1 point more than 3 standard deviation from central line is special cause. 7 point in a row are same side of centering, either in upside or in lower side. 6 point in a row are increasing or decreasing, means either upside increasing or downside decreasing. 14 points in a row are alternating up and down, that is up and down, alternating up, alternating down, up down, that is also a special cause criteria. And 2 out of 3 point greater than 2 standard deviation from central line, means same side. And 4 out of 5 point greater than 1 standard deviation from central line, same side, is also special cause criteria. 15 point in a row within 1 standard deviation of central line either side, either up or in downside. 8 point in a row are greater than 1 standard deviation from central line either side. Note, except for the first criteria, the numbers associated with the criteria do not establish an order or priority of use. Determination of which of the additional criteria to use depend on the specific process characteristic and special cause which are dominant within the process. Second note is care should be not to apply multiple criteria except in those cases where it makes sense. Means process what is the first criteria? That is 1 point more than 3 standard deviation. Means no point should present more than 3 standard deviation. That is important. A special cause criteria. This is the actually a graphical plot. First is point beyond the control limits. In diagram we are seeing the 3 points are in first diagram. In the X bar chart, 3 points in 2 points is upper control limits, beyond the upper control limits, and 1 point is lower control limit beyond the lower control limits. And in our chart also a point is beyond the upper control limits. 7 points in a row are one side of alternating up and down. One side of the average means average are center lines. This is example. And another example is 6 points in a row that are constantly increasing or decreasing. That is, first example is constantly decreasing and second example is increasing. Normality test. About half of the point should fall above the average and half below. Half should be above and half point should be below. That is normality test. Second, 2/3 of the plotted points should lie within the middle third of the region between control limits. Okay, these 2 points are the normality test. And some example is also too close to the average. If all the values chart are very close to the average values, then this is also the non-random pattern. And cyclic, continuously up and down, that is cyclic process. Some values are in up, some values are in down, continuously some are up again down. Too far from the average, values are away from the means too far from the average, and too near to the average is also, very near to the central line is also is criteria that already explained. Find and address special criteria. Recalculate control limit. Exclude all subgroups which are in out of limits. Recalculate the control limit for both range and average chart. Repeat the recalculation of control limits up to all points come within the control limits. Okay. These are the control charts for variables. This is continuous. Actually, X bar control chart for variables is average chart, and S chart means standard deviation chart. Average and standard deviation chart. What is the simple standard deviation? S is under root summation of xi minus x bar ka whole square divided by n minus 1. S means standard deviation, where xi is subgroup individual value, x bar is average, and n is sample size. Control limits. Upper control limits for upper control limit for standard deviation is, that is B4 into S bar, and lower control limit B4 multiplied by S bar, and average is UCL x, and UCL x bar is UCL x for average. UCL x formula for upper control limit is, that is x double bar plus A3 S bar, and lower is x double bar is minus A3 S bar. There is no control limit for the ranges for sample size below 6. Estimated process standard deviation is sigma is S bar divided by C4. This is the plot of X and S control charts. XM and XMR and R chart means median and range chart. For median, sample size, odd size are most convenient. Median is X M bar, can be denoted by XM bar or X bar. Okay, median XM, average is x1, xm1, xm2, xm3 plus xm and k divided by k. Upper control limit UCL x m is D4 R bar, and R is D3 R bar for range, and for XM for range upper control limit is D4 R bar as usual, and for lower control limit R chart is D3 R bar. For average means for average formula is UCL, that is equal to UCLS, that is equal to X double bar means XM bar plus A2 R bar, and for lower control limit standard deviation is X double bar minus A2 R bar. Note there is no control limit for ranges for sample size below 7 as usual in X bar R chart. Estimated process standard deviation is sigma is R bar by D2. X MR chart for individual and moving range. Used in case of subgroup variation approximately equal to 0, homogeneous batch measurement and single destructive tested. XMR chart is less sensitive as X bar R chart. Take care of not symmetrical distribution, piece to piece repeatability, number of subgroup greater than 100 before X bar can have substantial variability. Moving range MR, difference between each successive pair of readings. Readings are value. Means what are the differences between 1 to 2 values or readings, or between 2 to 3 readings, or 3 to 4 readings. This is successive pairs, means continuous pairs. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Are in rare case large moving groups 1 to 3. We can grouping 1 to 3. What are the differences between 1 to 3, 2, 3, 4, 3, 4, 5, 5, 4, 5, 6, 5, 6, 7. These are the process average. Process average is x1 plus x2 plus x3 plus xn divided by k, xk divided by k. MR is MR1, MR2, MR3 plus moving range MK divided by K minus 1, range average. This is process average, this is range average. K minus 1 for successive pair readings, K minus 2 for 3 successive reading pair. K minus 1 for successive pairs means 2 readings. K minus 2 for 3 successive reading. If we are using 3 successive reading means 1 to 3, then K minus 2. If we are using 2 successive pair, K minus 1. Okay. Used in case of subgroup variation approximately equal to 0, homogeneous batch measurement and single district test. Already explained actually. X MR chart for individual and moving range continuous is for average UCLX, right side given, UCLX and LCLX how to calculate. X bar plus minus E2 into MR. Okay. And for ranges means UCL MR and LCL MR. UCL MR is D4 MR bar, MR bar, and LCL is D3 MR bar. That's already noted explained in X bar R chart, X bar S chart. There is no control limit for ranges of sample size below 7. Estimation process standard deviation is sigma is R bar by D2. Control charts for attributes. Control charts for attributes. Subgroup size. Actually N denoted by N generally required quite a large subgroup size, that is 50 to 200 or more subgroup size. To be able to detect moderate shift in performance. To have analyzable pattern, the subgroup size should be large enough to have several non-conforming items per subgroup, such that NP greater than 5 subgroup size if constant is better should not vary more than 25%. Large subgroup size may be disadvantage if each subgroup represents a long period of process operations. Number of subgroup generally selected more than 25. The more preferable is. Data gathering. Actually subgroup size, NP and P charts large enough to disclose sufficient non-conformity per subgroup is small enough to avoid too long period of process operation. Subgroup size are generally 50 to 200 or more as explained. C and U chart. For C and U chart, the subgroup size in inspected area, subgroup frequency is consensus between fast feedback and a large subgroup size. Number of subgroup minimum 25 to give a good test for stability, and if stable, a reliable estimated of process performance. P chart for means proportion non-conforming. Non-conforming means for defective we are using per unit, we are using P chart. For defective we are using NP chart. Subgroup sample size N is not necessary constant, variable between plus minus 20%. Number of NC found NP, and proportion of NC non-conforming found is P is equal to NP divided by N. Process averages means P bar is N1 P1 plus N2 P2 plus N3 plus so on, and denoted by Nk is N1 plus N2 and divided by N1 plus N2 plus N3 Nk. Scale for the constant chart is 1.5 to 2 times Pmax. Control limits means UCL and LCL, upper control and lower control for P. The formula is for upper control limit is P bar plus 3 under root P bar 1 minus P bar divided by N bar. N. Actually, if N is varying, divided by N bar. N is the average sample size. And for lower control limit, formula is P bar minus 3 divided under root P bar bracket में 1 minus P bar divided by N bar, where N is particular subgroup sample size. Process capability will be 1 minus P bar into 100%. This is the plot of the P chart. For NP charts, for number non-conforming, subgroup sample size is N if constant. Number of NC found is NP defective. Process average is NP bar is N1, N actually N is constant, NP1 plus NP2, NP3, NPK divided by K. K is number of subgroup. Control limits is UCL, NP. Upper control limit NP is formula is NP bar plus 3 under root NP bar bracket में 1 minus N P bar divided by N, and that's simplification in simplified way. NP bar plus 3 NP bar minus 1 minus P bar. For lower control limit, formula is NP bar minus 3 under root NP bar 1 minus NP bar divided by N. And simplification format is NP bar minus, this formula can be simplified na, and NP bar minus 3 under root NP bar minus 1 minus P bar. Process capability by calculating is equal to 1 minus NP into 100%. This is chart for NP chart, means NP chart. These are the plot actually. This is table how we can plot is, how we can calculating the upper control, lower control and its capabilities. C chart for non-conforming product or parts. Sample size has to be constant. NC for sample is denoted by small c. Number of samples denoted by small k. Process average is C, means denoted by C bar, that is C1 plus C2 plus C3, that Ck divided by K. Control limits, upper control limit is equal to C bar plus 3 under root C bar. Lower control limit is C bar minus 3 under root C bar. Process capability is equal to 1 minus C into 100%. This is the chart for C chart, and this is table for C chart, how we can plot the C chart. Okay, for U chart, formula is same. C chart for number non-conforming per unit. Actually sample size is spread on a per unit basis, that is per square meter, denoted by N. NC per sample is, that is U is equal to C by N. Process average is U bar is, that is equal to C1 plus C2 plus CK divided by N1 plus N2 plus N3, that is NK. Control limits is UCL, U upper specification, upper control limits is, that is U bar plus 3 under root U bar divided by N. And for lower control limits, its formula is U bar minus 3 under root U bar divided by N. N is the average value, actually average sample size. 0.75 maximum values will be less or equal to, N should be less or equal to 0.75 max and greater or equal to 1.25 and minimum. Process capability formula is 1 minus U into 100%. Thank you so much.